Number 34, I just want to show you, I'm going to show you A and C, because C I think is a confusing one, and once you see C, I think you'll understand how to do like D, and once you see A, you'll understand how to do B. So here I have, okay, it says using the data from Appendix E, calculate the standard EMF of each of the following reactions. Okay, so I'm going to break this down, as I always do, into half reactions, which makes this actually very simple, because I got H2, which means that it's 0 in charge, and 2H with a +1. Now that means I have 2 pluses on the right-hand side, so I cancel that with 2 electrons, just like that. And then what we know is that the reduction, basically, this is the definition of the reduction, which means that this is the one that's 0. Okay, so when I do the next half reaction, so that's oxidation. So that means I'm looking at reduction here. So that's F2, that's grams like that, that's 0. But over here, 2F with a -1, which means I have a total of a -2 on this side. And over here, I have 0, so I need 2 electrons over here to make it a -2 on this side. So when I do this, now I have my reduction, and this one's a pretty big one. This is 2.87. You got to check the Appendix E, and what you'll be looking for is obviously you'll be looking for this. And some students ask me, like, what happens if you don't find, when you find that this one here, the oxidation, this is the one that's oxidation because the electrons are on the right-hand side, and the red is the reduction. Do you see why I keep using red for reduction? Because it's a reduction and it says red. So you will see all of them on Appendix E written as reductions. You will see all of them written, all the oxidations written as reductions up here also. So what you'll actually see in the book then will look like this. It'll look like this with 2 electrons like this, and it'll go to H2 as a gas, like that. So you will see this, and you will see obviously 0.00 volts, okay, for E reduction. So you do not have to change this number at all when we talk about the E cell with the reduction at the cathode minus the reduction at the anode. Okay, so that's what we're going to do. We're going to do E cell. So E cell goes like this. It equals E, the reduction, but that's at the cathode. Okay, which means that says, that's awful there, at the cathode. Okay, minus, and then it's E cell, not E cell, E reduction at the anode. Okay, so cathode is reduction, anode is oxidation. So we just simply plug them in then. So this looks like E cell equals, and then at the cathode is in the red, which means the plus 2.87 minus, and then whatever we have for this one here, which is minus 0.00. Okay, just like that. So that gives me a plus 2.87. I believe that's what it is. Check Appendix E. I kind of went off of memory on that one, so I'm not sure if that's exactly it. Now let's take a look quickly at Fe, and I'm not going to do the whole thing for you, but what I am going to show you is that, of course, we have 3 Fe's with a +2. We're going to have to break them up. One of those Fe's is going to go from a +2 to 0, and that means that I'm going to need my 2 electrons on the left-hand side, so that equals 0, and I have 0 here. This is our reduction. Okay, this is what happens at the cathode. Okay, so I'm allowed to split these 3 Fe's up. These 3 Fe's do not have to stay together and do exactly the same thing. So the other 2 Fe's that are a +2 here then go to the 2 Fe's that are a +3. And because they go from +2 to +3, they move right on the number line, which means that I'm going to need 2 extra electrons here, which makes this oxidation, which makes this anode. Okay, so that means that when I do my E cell, I'm going to look those up. The ones that go from Fe +2 to 0, okay, that's going to be my reduction. That's going to be this one here, RED, and that's going to be the one at the cathode. And then it's going to be minus, and then the one at the anode is this one here, RED, and that's the one at the anode or the oxidation. That's the one where obviously this goes here and this one goes there. Okay, look those up in the book, put the numbers right in there and just subtract the one from the other. That's it. It's just so I wanted to show you the half reactions here because we haven't seen one where we got to split up the reactant into two different things. Okay, that should be good. You guys, good luck with that. Please finish B and D on your own.